Hi everyone, good morning. Welcome to the session. Welcome all. Very warm greetings from Mercy Technologies. Right? Let's move forward to understand what is our agenda for today. The agenda for today is to solve these four questions. Implement a queue using two stacks. Implement a stack using two queues. Implement a stack using one queue. Implement two stacks using a single array. Right? So we have done the implementation of stacks and queues using arrays and linked list. We have learned about what are the different ways, what are the ways to find out the best, the time and space complexity. Should we should we go with the inserting it left or right? What happens internally? Uh, right, all this we have done in our previous classes. Now our our actual intention is to find out how do we code for this kind of questions, right? So what is our approach? Our approach is a simple approach, which is by taking examples. We'll take simple examples and we will be achieving what we need to using this approach. So let's see the code straight away. Let's go with the implementation. But seeing the code in the sense I told you, we need to develop the code using simple examples, right? So, which means I'm doing the same thing over here right now. What is that? Let me go to my Microsoft Word whiteboard and try to write the question. So what is that? Use implement queue. What is that? Using two stacks. Right, let's try to take whatever is given in our question right now. We'll be taking two stacks, right? We'll be taking two stacks. Okay, this is my stack one. I'm naming this as S1. This is my stack 2. I'm naming this as S2, right? I'm naming this as S2, and I need to implement a queue, right? Let's say I am implementing a queue, something like this. I'm naming this as queue. I've taken some examples or names like this. Maybe while writing the code, we will take better naming convention. Okay, so here let's try to do this particular thing. We need to do NQ and DQ operations, right? When I say that I'm implementing a queue, which means I need to support two operations. What are those? First thing is NQ of int x. Okay, and there is one more operation that I'm trying to support, which is DQ, which is not taking in a parameter, but it's just DQing. Let's try to take examples case. I told you we'll be solving this only by taking examples, right? So here I'm trying to take example something like this: NQ of 1, NQ of 2, and NQ of 3, right? Let's say I've written these three. Okay, so fine, we'll be inserting these values into our queue. Let's say 1, 2, and 3, right? So my front is pointing out something over here and my rear is pointing out over here. So there is this S1 has this top 1 and S2 has this top 2, right? These are pointing to -1 as their indexes. With this point, guys, let's try to implement our NQ method. Maybe I'll try to write code for NQ method. So what is my code? My code would look simply like this, right? Void NQ, right, of int x. So you have taken something like this. So at this particular point, what you will be doing is, I'll say s1 dot push of x. Simple code, guys. Let's say I'm trying to push it like this. Okay, I'm trying to push it like this. So what happens? For example, I say s1 dot push. So I'm pushing these three elements. What is that? 1, 2 and 3, right? So what happens, my top 3, top 1 will be pointing out to my 3 right now. So that's fine. We have taken these examples till now. Let me add a few more examples. I mean, few more inputs, right? Now I'm calling this DQ. So when I say DQ, so which means our Q should be removing an element from front and inserting an element from rear, right? So which means it needs to remove this value called 1. So when it needs to remove this value called 1, how can we do that? We have all our elements in our stack right now. So we do not have the hold to this number called 1. So that's why what we can do is we can do something like this. We can transfer all the elements from S1 to S2, right? Let's say we try to do that. We try to do that. S1 dot S2 dot push of S1 dot pop, right? What happens? You're removing this. S2 dot push of S1 dot pop. You're doing this and you're doing this, right? Something like this. All these elements would be gone and my top 1 will be pointing again to here and my top 3 will be pointing to 1. So that's why. So I can return this 1, right? So I can return this 1, which means now I have this value of 1 stored in top 3, and at this index, if I return this value, which should be, I can achieve this DQ operation. Let's try to write code for the same. So what is that? I'm saying something like this: int DQ, right? So what am I trying to do? I'm trying to do something like this: while S1 dot is S1 dot is empty. Simple. Until S1 is not empty, what you're trying to do is you're trying to do something. S2 dot push of S1 dot pop, right? Something like this you're trying to do, and let's try to dry run the same code for us right now. We'll be doing the same thing. So what is that? We are saying we are doing the same operation, the one that we have taken in our example. We are doing the same operation and we are able to achieve. And what we need to do, we need to return S2 dot pop, right? We need to return S2 dot pop. Okay, so this is fine until this particular point. Now, so what am I trying to do is, let's say I'm doing this NQ operation, right? Maybe I'll try to do NQ of 4, right? So which means my 4 would be inserted something over here and my top will become pointing to 4, right? So here, after I do this NQ operation, now let's say I'm trying to DQ something. So my 4 comes over here, 1 is gone, right? So I'm trying to do this DQ operation. So when you're trying to DQ, you need to return 2, right? You need to return what? You need to return what? 2. So you need to return 2. That's fine. Who is pointing to 2? Who is pointing to 2? Nobody, like, I mean, 2 is already pointed out by this value called top 2. So which means what I can do is I can straight away return this 2. So instead of coming here s1 dot is empty, etc, straight away we can return. So which means I can write a condition something like this over here. What that condition says, if, what is this condition saying? S2 dot is empty. So S2 is not empty. When S2 is not empty, then what you do? You return what? S2 dot pop. S2 dot pop. S2 dot pop. That's it. So with this simple if condition, you are able to return the same thing, and you are able to achieve the condition, whatever the DQ or NQ operation does, right? This is so simple code, guys. Let's straight away go into Eclipse and see what I have written. It's the same code. Okay. So it is my queue using two stacks. We have previously in our classes have written this classes. What is that? My stack array and my stack array and my queue array. These things we have achieved or implemented all those. So I'm taking these two right now. So what am I trying to do in our in like, as I told you, we'll be using a better naming convention in our programming. So I am taking two stacks, which are insert stack and delete stack. So these two, what am I trying to do as part of my enqueue operation? I'm trying to push something. As part of my dequeue operation, I'm trying to check this condition. If this is not there, then you have a while loop. After that, you delete. I mean, you just pop out the stack that you have right now, and finally, you will be able to achieve this dequeue operation, right? This is so simple and very easy, elegant code, guys. So now let me go to what is this? Implement queue using stacks, right? Implement queue using stacks. So now this is my problem description. I came to lead code. Okay, I came to a lead code. Here's my problem description and all. So it says you can read it out, and finally what we will understand, is we need to implement these methods, right? Let me move this down 1 second. Okay, so what it says is we need to fill in these methods, which is push or pop or whatever. So what I did in push, I just took the code what we have written on our Eclipse and I pushed it. And in our pop, I tried to do the same thing, right? I tried to do the same thing. Maybe here, instead of checking not empty, I'm checking empty. It's the same code. And finally, I'm returning s2.pop. Simple. This peak method also they wanted us to implement. This is almost equal to the pop method, but you can just have a look on that and try to implement that. So here what I want to say is this push method and this pop methods are the ones that we filled in with the logic that we have written in Eclipse. Now let's try to run this code. So we are able to run it properly and it's accepted. Let me try to submit the code. It says the same thing as maybe it depends from system to system. I think it's faster than 10.94 Java online submissions. Maybe I'll try to submit once more. Let's see if it takes any better. Right? Okay, that's fine. I think it depends on the computers or maybe at that particular time and all. But our code that we have written is the code that that runs and it passes all the test cases, guys. And after I submit, I see the same thing. So here are the different conditions or different submissions that I made, right? So at this particular point, what I want to explain you guys is like the code. Just by looking at this code, it's not that hard. It's very simple. It's very simple and elegant code. So but you need to understand what happens actually internally to it. So taking examples is one approach that makes you to write code in a better way, right? That makes you to write code in a better way. Now let me go back to my whiteboard and explain you one important concept. So what is that important concept saying? That important concept is saying something like this. It is amortized time complexity. So let me write it down here. Amortized time complexity. So what is this amortized time complexity saying? But before that, let's try to analyze the time complexity for this enqueue operation. The time complexity of enqueue operation is order of 1. The reason is in our previous classes we have seen something like this. What is that? Right? When we try to insert something at end, the time complexity will become order of 1. So because of this, the time complexity is becoming order of 1 for our enqueue operation. But what about our dequeue operation? If you observe, when we call this dequeue for the first time, we try to move all the elements from one particular stack to the next stack, right? So which means we are doing that. For example, let's say the length of the stack is 1000. We are trying to do that 1000 times. The length of that stack is 10,000. We are trying to do that for 10,000 times, which means it is directly proportional. So when it is directly proportional, we can say the time complexity will become order of n, right? So this, at this particular point, I want to again explicitly say one more thing, that it's not that every time you call this dequeue method, you'll be doing the shifting operation. It's not like that. When you try to dequeue again, so it's not that you will be what you call doing the same operation, because we have this condition s2 dot is empty, then you try to return. So which means s2 dot has some values in it, which means it is able to return it straight away without even coming to this while loop. So what I say is, this particular operation, what is that? S2 dot is empty, then return s2 dot pop, which means one dequeue operation is taking order of one time complexity, but that doesn't mean that every dequeue operation is taking the same time complexity. All right, it is happening once, or maybe it is happening rare. So which means that's why we can say theoretically the time complexity will become order of n, but we can say it's an amortized time complexity. Amortized time complexity means uh, at one particular point you are able to do something, and that takes this order of n, and that doesn't mean that it needs to take this order of n every time it does the same operations, which means a dequeue operation. All right. So with this guys, what I want to tell you is, just by taking a small example like this, we have taken the problem statement, we try to achieve or try to draw diagrams of whatever we are trying to achieve, and finally I took small example in queue of 1 2 3, and I started dequeuing, again enqueuing, again dequeuing, etc. By taking these small examples, we were able to write code for enqueue, and we were able to write code for dequeue, right? So this is what I want to teach you today. Like, just by taking small examples, we can develop our code, and our code can be actually used uh, to submit that inside this lead code or HackerRank or whatever. So we shouldn't, whenever there is some problem statement that's given to you, we shouldn't blindly go and start writing, right? We'll be having a pen and paper with us. We can start writing, take examples and start writing the code, something like this. And after we complete developing, and after we dry run and make sure that it is working, we can take the same code and we can write it over there, we can submit, and chances for us to complete the submission successfully are very high, right? So with this particular point, guys, I want to end today's class, and we'll be seeing about the other problems that I have told you in our today's agenda tomorrow, because of the time constraint. Okay, so make sure you're practicing everything properly, guys, and only practice is very important, because you can take examples only when you practice, right? Only when you practice. So before leaving, there is one more thing that I want to say. What is that? I told you we need to take care of all the base conditions as well, right? All the base conditions as well. But here I did not speak anything about the base conditions. But one thing that I want to say is, we have achieved all these base conditions. All these base conditions is empty, is full, etc., etc. We have achieved all these base conditions in our previous classes itself. So that's why, even though when I try to enqueue something which is out of bound, then it prints the same. When I try to dequeue something which is an empty one, then it prints the same, because we have taken all those cases into consideration in our implementation of my stack array, right? So with this particular point, guys, uh, let me tell you that we are going to end the class for today, and please practice and post the same so that we can continue our class for tomorrow. Have a nice day. Bye bye.